All right, so I said that we can now apply these to problems where you want to arrange letters from a given word, right? And I've changed the word here just to make it a bit easier because I want to talk about duplicates a bit later on when we get up to this part. But these ones here, you can still think of it as selecting n objects. So what are your objects again? They're the individual letters, right? So how many letters do we have in numeracy? 8. And so we're selecting 3-letter words. I put words in quotations because this time that sort of addresses the issue we had before with what's a 3-digit number. So even if you did like NUM, it's not really a word, but we'll count it as a word. That would just be 8P3. Now often when these numbers get bigger and bigger and bigger, we don't always have to write it as the number itself. You can just write it as 8P3, but what is that, for example, in this case? When you calculate it in? 336. Which is not too bad. Thoughts for part 2? How would you do that one?
8 factorial of 8 minus 5 factorial, which is 6,700.
Yeah, so you can just do 8P5. And what did you get? 6,720. I feel like we've calculated before. So some of these numbers might get more familiar over time. Here's where it gets a little tricky, right? So just in terms of arranging words, why did I do Bob twice? Just in terms of arranging words, I'll put in B's. So, just in terms of arranging them, there's a few things you have to consider. We've already looked at just arranging how many there are if there's no duplicates, right? How did we actually look at arranging them when there's no duplicates here? What do you have to think about? You think about the number of spots you have, and there's no repetition here, right? Here's the number of spots I have, for example, for crane. And how many letters can I choose from in that first spot? 5, and then, which we know is just 5 factorial. So that's not too bad. Is that making sense so far? Because then this is where I need to sort of address something new. Because this is just going to be 5 factorial. But remember, what's the issue that we had? I think 5 factorial is 120, by the way. So you can put that in too. What's the issue we had with something like this, though? Same letters, right? And so Sophie's question before, when I got to my name, was, do we treat the I's as individual ones? Are they like their own thing? Like if you want to say B1, and what are you thinking B2? So I think what we need to do is sort of just, everyone likes me guys, right? I think what we need to do is we need to think about, okay, if we were going to treat them as individual ones, that would make it a lot easier, because then what would the calculation be? It would just be, like if they were individual, they're different, you could just treat it like you would any other problem. Would you agree? Because you can just do, well, these are different, so if I do BBO, that's different to BBO, because technically you could do something like that, right? But that would kind of be cheating, and that would be making things a lot easier. So we want to think about how can we actually address this. What's the issue at hand here? The issue at hand is technically these are the same thing. And so when you list all of these out, right, and there's not too many, divide by, we can just halve them. Why are we doing that? Because all of the arrangements, let's just write them out because there's not too many. And OBB, I think that's the last one, is that right? Okay. Because there's these duplicate ones, we can just halve them, right? So what would that calculation look like? 3 factorial, my marker's dying. I don't know if this one's any better. No, this one's worse. 3 factorial over 2. Now I just want to make a disclaimer here because it's going to work for all of these conveniently because there is actually only 2 repeated letters, okay? So I'm just going to come back to what our actual formula for this will be in a moment, but let's just use this approach for now. Kim Singh, same idea. So now we know how to address this issue. How many letters are there in total? 7. So usually that'd be 7 factorial, but what am I dividing by here? 2, just 2, because we know that we can swap these i's around, okay? Same thing, last thing with B's, you can jot that down. And then I'll write a few more for you. So let's have a look at this. Now I have to make a disclaimer because for these ones, the only thing that's happened is we had to divide them by 2, right? But really what I should be saying is this, like why are we dividing by 2? Because there's a digit repeated, or there's a letter rather, repeated twice, okay? And so when we get to things like this over here, bees, bookkeeper, Antarctica, noon, there's going to be different number of repetitions. And so actually, so this one is still fine. How do I approach this one? How many letters are in total?
4 factorial divided by 2.
Yeah, 4 factorial divided by 2. What happens when we get to things that are more complicated? I want to skip to Antarctica for a second. Because how many repeated letters, or actually, first of all, how many letters does Antarctica have?
1, 2, 3, 4, 5.
Have I spelled this right, by the way? Looks right.
I guess so, yeah. 10.
10? Okay, so you read 10 factorial. Now, actually, what's happening? Think about these A's here. If we were just having a repeated number of A's, I mean, to make it really simple, let's look at just AAA. That's not a word, but let's just treat it as it is. How many ways would you be able to arrange it? It would be 3 factorial normally. But what do we have to divide by, though, do you think?
3.
Well, then you're saying then, that would be, what's 3 factorial over 3?
1.
2.
Oh.
Yeah.
6 over 2.
So that's a bit strange, isn't it? Right? Because shouldn't there, how many ways can we actually arrange AAA?
1.
There's only one arrangement. And so what you actually have to do is you have to divide by the number of times it's repeated, but then you have to add a factorial at the end. Can you see that? Because that's actually what's happening with these ones. These are all actually divided by 2 factorial. It's just that 2 factorial is just 2 anyway, right? So what you have to do is you have to divide by the number of repeated words factorial. I'll write that out as a little formula for you just before you go. These ones can be your homework because the other guys aren't here, so I won't give you too much while they're away. So here's our last formula. I'll write this down. So the total number of arrangements, this is for repeated words. This is our kind of formula. Divided by number of identical spots, factorial.
So,
Yeah.
what was the answer to Antarctica?
Well, let's just finish it off. How many repeated words are there? So,
There is 1, 2, 3,
And 2
7.
C's.
okay, so we actually have to treat them separately each time though, because they're not all just the same repeated letter, right? So 3 A's, so that's 3 factorial. And then we're going to divide by these separately.
1 factorial and then 2 factorial.
So the 2 repeated T's and the 2 repeated C's, well done. You can try these next ones yourselves, okay? Make sense? Alright, try those off for homework. I will catch you period 6.
Oh, yeah.
Do you get to do fun Monday?
Fun Mondays, of course you do fun.
Valentine's craft.
Oh, Valentine's Day math. And just to finish this last few off, so bookkeeper, for example, again, same idea. Using this formula, we can say, all right, how many different letters have I got? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, I should rephrase, not different letters. How many letters are there in this word? It's helpful if you have a marker that works. There's on the chart. 9 factorial. All right, because that's how many letters there are, divided by, now these are the repeated ones, right? So we've got these 2 here, the 2 O's. Oh, actually, we've got 3 E's, don't we? So, and this one. So it's, remember, we can't treat these as all repeated. They're not all able to be arranged within each other. It's only, for example, these 2 that can be arranged within each other, which is 2 factorial. And then how many ways can you arrange the 3 E's between each other? So you can swap them around in particular ways. That's 3 factorial, okay? So you can go ahead and calculate that for me. And still a pretty big number. Looks like it's going to be 30,240. Last one, noon. A lot of repeated letters there, so it's going to be Again, same idea, right? Total number of arrangements, so that's 4 factorial divided by how many times it's repeated. So it's 2 factorial for the n's and then 2 factorial for the o's. Just be careful with this one because there's kind of like a false sense of, oh, these all just sort of divide and cancel out. But just remember, what does 4 factorial actually mean? It's 4 times 3 times 2 times 1. And this is just 2 times 1 times 2 times 1. And so actually what's the only thing that's going to cancel out is this 4 here. So 4 on the denominator, 4 on the numerator. And so you just get left with 6 different ways there. Okay, so that's permutations with restrictions, applying them to choosing letters from a word or just arranging the words in a particular way.